that respond? Yeah, okay. That was pretty quiet. Let me see if I can do that again. Yeah, it's recording. All right, I'll trust that it's doing what it's doing. Yes, the record light is on. Okay, great. Oops. Uh-oh. There we go. So why don't we get started? Good now afternoon. My name is Dr. Gary Holness, and of course, you're here for CS 268 Internet of Things. Today, we'll be talking primarily about introductions and overview. We'll also be choosing teams. And to do so, I'll give you a choice about how you'd like to choose teams when the time is right to do that. And so I like to begin each class with the administrative slide. And I use abbreviations for the text. And so Garfield says hello and welcome. I'm a big fan of internet memes, as folks who had me last semester in Stochastic can tell you. The reading for a week, do a week from today. I'm not going to test you on the reading. I just assume you're going to get it done. The reading is important for the activities that we have planned for Friday as well as going forward. Things will build upon one another, so it's going to be really, really important for you to help me, to help you succeed by making sure that you're staying on top of all the work. Okay, and so the reading by Tuesday, a week from today, chapter 1 in the Arduino text, pages 3 through 21. In the Design Thinking Playbook, text, DT, as I'm calling it, pages 4 through 12. They're very easy reads, and project 1 is out, and this project 1 is intended in getting to know, quote unquote, you. So it gives me an opportunity to get to know you an opportunity to get to know your teams, which we will form, and also to understand a little bit about yourself and hopefully improve team dynamic throughout the semester. And so that's all on the Moodle site. I like to do things electronically. In my previous institution, where I spent 11 years, we pivoted to complete digital 2 years before COVID struck. So it was a non-issue when we pivoted to remote. And so I like to use the Slack messaging system, and thank you everyone for joining it. Everyone's up on Slack. And I use that as the primary method for communication. That's to the class, but also in Slack, you can do individual messages. And so it allows me to better manage my message to you. Email, I'll try my best to respond to email, but please know that I get probably 50 to 100 emails a day about various things. You know, you do some research and faculty member and all sorts of people contact you trying to sell you all sorts of things. It's kind of incredible. But that being said, it's very easy for me to miss your email because I get so many of them if you send me email. But Slack, my phone buzzes, I look at the Slack mobile client, I go online, look at the channels, and I can more easily organize and manage all of those messages. So I'd really appreciate if you all would use Slack. If it's something really, really important and you feel email's best, please know that I might miss it, right? I check email regularly, but it's too unwieldy for me to manage. So please help me to help you best by using Slack. Okay, any questions? No questions? All right. So what we're going to do for you, in addition to the ramp up for project 1, look through the material on the Moodle site, get yourself acquainted to it. I'm not sure what others do in terms of how they run the courses, but I'm a fan of content management systems and course management software. We use Blackboard at my previous institution, and so I've sort of had to get a crash course in Moodle last semester, and I'm continuing this semester. You're all on Slack, so that's a moot point. Make sure, please, to read the syllabus and install and run the Arduino IDE. We will be going over a series of tasks on Friday for the lab session to walk you through soup to nuts to getting your first program running on the Arduino platform. And so if you've never tinkered with hardware, you're in for a lot of fun. If you do tinker with hardware, you're still in for a lot of fun. I get a thrill out of it still after all these years, and I hope that by the end of the semester, you'll learn to love, sometimes hate, the hardware platforms. Okay, so let's start out with some introductions. I also have a class roster. Some of you I know from last semester but many of you I don't know because I've never had you in the course. And I've been at Clark now for 5 months. So I wouldn't have known you throughout your freshman year, sophomore year, et cetera, depending on what your status is in the curriculum. And so let's begin with you, please. And please state your first name and what you hope to get out of this course. Okay. All right. Hi, Adriana. Welcome to the course. And Nguyen, I know you still. And what do you hope to get out of the class? The same thing? Okay. Now I have one ear covered up, so it's kind of hard for me sometimes to hear. So let's have you. Yes. Caleb. Hi, Caleb. Okay, great. Welcome, Caleb. And you are Jack. Hi, Jack. Okay. And well, with a bigger mouth, it's hard to see. Nathan. Hi, Nathan. Okay, just the pie or not the Adreno? Just the pie. Okay. All right. All right. Han. Hi, Han. I know you, Han, from last semester. Okay. All right. Okay. Well, we'll touch on a lot of stuff. Welcome back. Last semester. Keegan. Uh-huh. Okay. And how about you? Welcome back, Keegan. Kenny? Okay. Ah, okay. All right. Whew, I have a lot to live up to. All right. And how about you? Yes, Jeffrey. My best friend's name is Jeffrey. Oh, okay. Uh-huh. Okay. Well, you'll have a lot of fun, I promise you. All right. How about you? Welcome. Tyler. Hey, Tyler? Okay. Wow. I have a lot of pressure, huh? All right. How about you, Jamie? Hi, Jamie. Welcome back. Okay. Whew, I'm honored. All right. Okay. Well, I hope it will be. I have a lot planned, so we'll see how this plays out. All right. Welcome back. How about you? Uh-huh. Uh-huh. Okay. Okay, great. Great. Welcome. And I know you, Cushman. Okay. Okay. Well, welcome back. Well, the welcome back are students they had last semester. So you're all welcome back to campus. Okay. How about you? Delasha? Hi. I owe you a meeting, you and your team for Thai. All right. Okay. Oh gosh. No pressure on wholeness, huh? Okay. Okay, great. Great. And last but not least, Sujan? Okay. Okay. Wow. So no pressure on wholeness there. All right. Last class, hardware. All right. So let's do this. So why don't we continue on? And of course, it'd only be fair for me to tell you a little bit about myself, right? So in my career, I really wanted nothing to do with academia, right? So why have I been a professor for some time? That's an interesting story for another time. And it's in a perfect example of how meeting one or two of the quote unquote right people at the right time can completely bend your trajectory, right? So I got my PhD in computer science at UMass Amherst, and my focus was robotics, machine learning, and statistics. And I actually took my first statistics course at UMass, and I fell in love with this thing. I said, "Oh my God, this is great." And statistics is particularly useful where I like to say the atoms meet the bits, right? When you interface with the real world, something messy but wonderful happens. You get a lot of imprecision. And how you deal with imprecision is through measurement. And I'll talk a little bit about that throughout the course of the semester when the time is right. I did my master's in computer science at Boston University in parallel distributed systems. So I was looking at operating systems on supercomputers, and it was completely different from my PhD, which is more on the analytical part of computer science. And then in another complete mind bend and pivoting, my undergrad was in electrical engineering at Tufts University. And so I worked in a career after graduating while earning my master's degree. It's doable. I don't recommend it, but it's certainly very doable because your employer also pays for your master's degree. But the issue is time. It's always time or money, a classic trade-off. But that being said, I left industry and just left all of those, perks and things on the ground and went back to get my PhD full time. And that's a whole other story for another time. But that being said, I've been at Clark for 5 months, and I moved here from Delaware. I was in Delaware for 15 years, just sold my house. So I'm officially a Massachusetts resident as of last Friday. Anyways, if you know how to get a registry appointment, please let me know, as it's weird here. But that being the case, before that, I was at Delaware State University for 11 years, and it's in Dover, Delaware, which is central Delaware. But my career was 8 years in distributed systems R&D at Sun Microsystems and Lotus Development Corporation. Lotus is now defunct for a long time. Maybe you'll read about in the history books. But after or while I was finishing up my PhD, I spent 4 years doing machine learning on various sensory modalities and also mathematical modeling. Oddly enough, the mathematical modeling was for disease spread models, right? And that was for avian influenza. So now that we have COVID, right, it's kind of interesting to see the models that they're using. But that being the case, more than that, I spent a lifetime of tinkering and hacking, sometimes successfully, sometimes not successfully earlier on throughout my life. And what I really hope to do is build in you this sort of experimentalism where you can find and identify a problem and craft a solution to that problem. And so this course carries the designation of C2C, which is curriculum to career. And because of that, I got a course development grant, which is what's purchasing all the materials, in addition to some of my own money from my lab, that you're going to use for the project. And what C2C says is that in your education, you need some practical skills that are useful in the marketplace, be that graduate school after your tenure here is done, or in industry, because they're skills that are certainly very important, but they're not things that are taught at all, really. You kind of pick it up by osmosis as you go on in your careers. And my proudest, or some of my proudest accomplishments, are the students that I've mentored. And it's a mix of mostly undergrad, but some grad students. And they've all gone on to very successful careers, right? You name it, Apple, Microsoft, banks, small organizations, big organizations, Army Research Lab, all sorts of things. And so it's really important to me that I can instill some of this experimentalism, but there's going to be stuff that you're going to have to do. Really? Yes, you're going to have to do. Now, I once used to say, it was considered controversial at my previous institution, I can't make you learn. I can help you learn, but I can't make you learn. And in this contract called learning, there are certain responsibilities that you have. Right? I can't make you learn. Now, in Jamaica, you'd say you can bring a donkey to water, but only the donkey can make himself a drink, right? But, oh, I just said it. All right, there we go. So what are we going to accomplish? There are 3 main points that we're going to go over this semester. Certainly, we'll look at the technical parts of IoT. So that's the hardware, that's the software, that's the sensors, the actuators, the hardware and software interface to those categories of sensors and actuators, in addition to the platform pieces. That's where the Arduino and the Raspberry Pi come into play, because each one has a different way of accomplishing things, of doing computation, and each one has a set of assumptions and programmatic interfaces that you're going to use to accomplish something. And so I'll also go over how you implement a finite state machine, because for these interacting types of applications, that's a very good way of implementing such systems, especially as from the Arduino's perspective, when your platform is um, very modest in terms of the memory and amount of computation. Okay, any questions about this? No questions? All right. We'll also talk about management of the creative process. Now, this is where the design thinking part of the course comes into play. And to be honest with you, I was a skeptic for design thinking until someone sent me to a training seminar for a week. And I'm like, oh my God, this stuff is really, really amazing. And so this is coming from a skeptic, but when you talk about the creative process, how you manage creativity, the conception of something from just an idea or set of issues, there's a process that you follow. Now, granted, you can cater it or season it to taste, so to speak, to suit your personality, your time frame, your needs, and so forth, but it is a process. And so we'll also talk about managing your work, working with others. Now, the days of sort of the computer scientist in the back room by him or herself, working in a dimly lit room, those days are long gone, right? They were long gone even when I graduated back in the Stone Age, right? You're going to have to work with others. And so working with others, it takes a lot of effort. And you need some specific skills to hopefully make it easier for you to work with others. How you identify an issue for solution is really, really important. Just because something is interesting, it doesn't mean it's something you should spend your time on in trying to enterprise to solve. And this last one, the triage of ideas and approaches, the analysis and the methodical consideration of various approaches to what activities you're going to end up pursuing or committing to time. And then, of course, the skills and techniques. We'll talk about things like how do you solder, because I don't think that's something that you've done before. A little bit of fabrication. Granted, we're limited on the tools. We won't be using CNC machines and 3D printers and stuff like that. But how you assemble resources, rapid prototype, the experimentalist skill set. Because for some of this stuff, there's not really a good book that tells you how to do it. You're going to have to assemble your own curriculum of resources from various sources on the web, library, and so forth. Okay? Are there any questions about this? And I have a note here to myself. As you'll notice, there's no teaching assistant for this course, right? So your teaching assistant is right here. Your professor is right here, right? And so what that means, the reason being, is that this course is brand new. And so there's nobody who's taken the course already. So there's good news and bad news. I'm your TA, right? Hopefully that's good news and not bad news, okay? All right, now this course will also be kind of an experiment for me as well in figuring out the logistics and how to teach this at this university, right? Because it is a quote unquote, what I'm calling a wet lab course. It's based on a lot of physical artifacts and a lot of techniques like what you'd have in a bio class or a chemistry class. And so having things like the facilities for you to go in and actually try stuff out. Where do we do this, right? And so right now it's going to be BP 310. So some things are still being worked out. And I promise you, as the pilots say when they, bing, ring that little bell, there'll be turbulence ahead, right? So please bear with me and know that you're sort of carving the path forward that others will traverse after you based on the lessons learned, okay? All right, so caveat, I remember this slide. There's 15 weeks in a semester, minus 1 week for spring break. I can't teach you every single detail. When I first designed this course or started designing this course, I had 15 textbooks that I could pick. And it's like, oh, that's a little bit too much. And I'm really sensitive towards trying to keep the cost down for the course, right? As best I can. And so what your responsibility will be, among other things, keeping a research notebook or engineering notebook. And we'll talk about some methods for doing that, but it's going to be really, really important for you to keep a logbook, especially because you're going to forget what you did last week or yesterday or the day before, and it allows you to pick up where you left off, have those notes to help you collect information that's important to your project. Now, it doesn't have to be a physical notebook. It can be a Word document that you continue adding to. It could be a blog. It could be all sorts of things. I've had students in the past that use GitHub or a public blog to do it. And when they're interviewing, they say, hey, take a look at my blog at all the wonderful stuff I've done. And that has led to gainful employment in an organization of their choice. Okay. So in addition, assembling curriculum of material and doing something every day, because it's skills-based, you're going to need that repetition in order to learn how to do things on top of just the theoretical material in the class. Now, granted, life gets in the way. I realize that some days you're going to get a lot done, some days you're getting a little bit done, but enterprise to accomplish something every single day. And I promise you, in the limit, over the days of the semester, you will look back and say, oh my gosh, I learned a lot. Okay. All right. Any questions? All right. And so your active participation is certainly welcomed, be that in class or through the Slack channel modality. I really, really get a sense of how things are resonating with you by your active participation. Okay. All right. Any questions? No questions? Anyone kind of nervous? No? Like, what the hell did I get myself into, right? Okay. All right. So the textbooks are threefold for the course. There's Exploring Arduino, which I'll abbreviate ARD on the administrative slide. There's the Raspberry Pi Cookbook, which I'll abbreviate Pi. And as I posted on the Slack channel, on the bookstore link, they have the description right for the Raspberry Pi book, but they have the picture wrong. And so if you made the mistake of just looking at the picture and looking for it, which I sometimes do, please make sure it's the third edition for the Raspberry Pi book. Okay. All right. Now we're going to be using material throughout both of these tasks. And so you can think of them as reference books, and I'll say this book or that book, section 1, pages such and such to so and so, but we're going to be using, based on what we're covering, various parts throughout the entire of these two books. Now, these aren't the only sources of material for the Arduino and the Raspberry Pi. Our library, and I did a search, has a lot of Arduino and Pi sources there. Also, the two de facto websites, raspberrypi.org and arduino.cc, are the de facto standards for all things Arduino and Pi. Okay. And so this is going to be a little bit different. You're going to have to assemble resources. If this book or these books do not resonate with you, please know that you're not just limited to these sources. I picked 2 books, so you could have atoms if you choose over bits. Now, I like paper, right? Old fashioned, but maybe you like the digital version. Okay, and there are lots of used versions available on Abe Books and other places. The other book is about design thinking, and it's going to frame our conversation of managing the creative process. And it's really a clever way that a company called IDEO has pioneered and enjoyed tremendous success. If you've ever used Apple products, IDEO was the consulting company on the design for many, many Apple products and other things as well. Okay, any questions? No? All right. So the boards. 2 boards you'll be buying yourself. And the reason for that is because of the budget, really. The Arduino, which is an embedded controller, and we'll talk about the difference between a controller and an embedded small board computer, which is the Raspberry Pi. So this is the Arduino Uno Wi-Fi revision 2, and it has to be the Arduino Uno Wi-Fi revision 2 and not the Uno 3. Now, of course, the naming can be a little bit confusing, I agree, but we'll get into on Friday's class module the different variations of boards and things like that. And so at this juncture, please make sure it's the Uno Wi-Fi revision 2. Now, if you are enterprising to buy a so-called clone board, these hardware platforms are open source. So you yourself could take the design files and go out and manufacture them and sell them yourself. Wonderful. So-called clone boards are organizations that sell boards based on these designs, and sometimes they modify them. And so part of the issue with the clone boards, there are really good clone boards that are compatible signal-wise and function-wise with the de facto UNO, the UNO Wi-Fi version 2, but some of them are not completely compatible. And that's the risk you run when you get a clone board. You have to make sure that, and it's usually from blog entries and Reddit posts and things like that, you have to make sure that if you're going to get a clone board, that it's compatible, because they're not always 100% compatible. Okay, so we have the Arduino Uno Wi-Fi revision 2. We have an example of a power supply, and this particular, excuse me, power supply is a 9-volt power supply, and we'll be talking about voltage and current and resistance and things like that. But this is a 9-volt power supply, and when you look it up, you want to make sure that the measurements for it are correct for the board. And so you'll hear or read nomenclature like a 9-volt barrel 5.5 by 2.1 center positive adapter. Well, the 5.5 refers to the diameter of the cylindrical barrel up there, and the 2.1 refers to the diameter of the inner part, and that's in millimeters. And center positive means that the positive voltage is on the center conductor lead inside of that cavity. That's 2.1 millimeters. Now, they might not all explain it this way, but please make sure that your power cord is compatible. You will also need a USB cable, a USB AB. AB stands for USB type A, connected to USB type B. It looks like the following. It has your standard USB 2.0, 3.0 connection on one side, and then it has this little kind of more small D-shaped connector on the other side. Now, when you plug in this connector into the Arduino board, it will power the board on this data cable. This data cable is used to download code onto the Arduino board, and we'll talk about that more on Friday, but it'll also supply power. So then why have a separate power supply? Aha, well, we have a separate power supply because some of the devices you can hang off of your Arduino board take more power than can be supplied through USB, particularly motors and things like cell phone communication. Yes, you can do cell communication on the cell network with the Arduino Uno. And we'll talk more about shields on Friday, more to come. This is the Raspberry Pi, and the Raspberry Pi 4 in particular has a certain amount of processing. And when you buy a Raspberry Pi 4, one of the choices you have to make is how much memory it has on board. Now, for the purposes of this class, the small format, 2 gig is fine. Now, just like when you buy a laptop or desktop, if you think you want to do more stuff later on, wonderful, you might need more memory. But for the purposes of this class, 2 gig is fine, right? You could get the 4 or the 8 if you want to, and the price point changes based on who you buy it from. And also, a lot of people, because they're in scarce supply, they scalp them, right? Don't pay a scalper, right? Buy from somebody who's going to sell it to you for a fair price. I hate the scalping. All right, anyways, so that being said, that's the Raspberry Pi, and there's a power supply for the Raspberry Pi. You want to make sure that the power specs for the power supply is appropriate for the Pi. Now, when you look up any board, it'll have a so-called data sheet that'll tell you how much input voltage it can take and how much current it needs, and we'll talk about voltage and current. But please make sure you have something that's at least 5 volts and at least 2A or 2 amperes of current. Now, if you drive this board hard, meaning if you run a lot of things on it, like you have a camera, you have some motors running, you have some sensors, you're doing some heavy computation, this board is going to consume more power, and you're going to need something that's more substantial in driving the board power-wise, okay? All right, and then lastly, the micro SD card. This is the micro SD card, small thing here. And it often, when you buy it, it comes with an adapter to allow you to plug it into the larger, I forgot what it's called, slot. Now, this micro SD card is a memory card, almost like a flash drive. And this thing plugs into your Raspberry Pi, and it acts like the hard drive for the file system for your Pi. The Raspberry Pi is actually a small board computer, full computer. You can do gaming on it, you can watch television, you can drive monitors, all sorts of stuff. And it's different from the Arduino which is a microcontroller, which is just very simple for controlling devices. And we'll talk about those differences when the time is right in the semester. Okay, any questions? No questions? No? You're all very quiet. There are other useful resources. Of course, the library has some wonderful resources. And one of the reasons for choosing the Pi and the Arduino is there's a lot of maker sources available for it, particularly YouTube videos for just about anything, as well as, people have websites you can Google search for it and things like that. Again, I've repeated the URLs for Raspberry Pi and Arduino. Okay, those are the de facto sources where you'll get things like libraries and tutorials and stuff like that. Okay, so assessment. You'll notice here, I have 8 projects collectively worth 40% and only 2 written homeworks. So this is going to be a bench course. You're going to be doing a lot of project work because the only way to understand IoT is to actually build an IoT system, right? And we're going to wrap the creative process in design thinking as a way to help you with the idea formation, requirements analysis, and so forth. And so for my final exam, I like to have a final project. So the final project will be your final exam, and it will be an original project that solves a problem tuned to improving some aspect of quality of life on campus. And it's going to be up to you to go out and find your customers. That's why we have the design thinking process that we're using to shape the creative process. An aspect of campus life or Clark University life that can be improved through an IoT solution. Now that seems very daunting because it's open-ended. Well, how in the world do I do that? Well, you're going to have to go out and understand your market segments, right? Your analysis of your market cohorts, okay? And we'll talk about that as well. We have 2 exams, and these exams might be reports, might be project. I haven't solidified all those yet. And we'll also have a class participation grade. Now, if I don't know who you are at the end of the semester, you kind of flubbed on your class participation. And class participation can include the Slack channel, office hours, the loneliest 2 hours in the week, or it can include your participation in class. So I really do encourage you to actively participate as well as in your teams. All right, so that being the case, it is a fixed grading scale. I use half-open intervals and closed intervals for the grading scale. I won't go over those. And my reasons for fixed grading scale is that I want to get away from this unhealthy curve mentality, right? You should be helping each other, right? Especially because it's team-based, and not worrying about what's going to happen grade-wise, not sacrificing a sacrificial lamb to make sure that the curve is good, right? They did that when I was an undergrad. So that being the case, let's pick our teams, and I'll give you the choice whether you want me to randomize it. I have names in a basket, or you want to do it organically. Now we need 4 teams, and we have a roster of 19 people. So we're going to have 3 teams of 5 and 1 team of 4. So should I randomize it, or do you want to leave it organic? I'm sorry? Organically? Okay. Organically? Well, because I'll pick random if you don't pick. So who would like organic? All right. So it's 1, 2, 3. Who would like randomized? Randomized? Who doesn't care? Okay. Now, I will let you do it organically then, but please know your friend isn't always the best teammate. Ooh, oh, that's cold-blooded. Your friend is not always the best teammate. So remember that. It's about how you work together. Some of my best colleagues weren't my best friend. It's not like we were kind of enemies, but working well together is all about personality match and personality mismatch. What do I mean by that? Okay, we'll talk about that. All right, so I'll let you do it organically, but what I like for you to do is please let me know by Wednesday, tomorrow night, and I'm trying to go to bed early this semester, right? So tomorrow night by 11 p.m., please let me know what your teams are, okay? Because that's going to be important. I'm going to bring the kits to BP 310 for our Friday session, okay? Yes. Okay. Yes, I can, like, now. Let me let me do it at the end of class. Just remind me, please. Okay. All right. Because this will be important to that consideration. All right. So these are the topics. I mentioned them a little bit. Hardware, software interface. We'll look at protocols for interacting with more sophisticated devices, connecting to the outside world, how you get data on the device, off the device, networking. Now, this is not a semester of computer networking, right? This is just enough to understand the underlying principles behind the APIs that you're going to use. I encourage you to take the computer networking course. Femi does a wonderful job, fantastic job. I've taught computer networking. I actually took networking with Jim Carrozza, the one who wrote your textbook at UMass. Throw that in. But getting things done, rapid prototype, and teamwork. Now, I mentioned teamwork and personality a bunch of times because oftentimes when you get people together, conflict arises whenever you have a misunderstanding, right? And I'll talk more about that. Some policies. Please get here on time, right? I will always begin at 12 noon and I will always end on time. Don't believe me? Ask a stochastic computing student. Does Holness end on time? Well, yes, he does, right? I do. I'm proud of that. Anyways, late assignments, make sure you get your assignments in on time. I do not accept late work. If you have extenuating circumstances, life gets in the way, I only ask you to communicate. Reach out to me and communicate, okay? All right, how to succeed in this class? It's all about engagement and teamwork. And this is one of my favorite quotes. I don't need Superman. I don't need a hero. Be Clark Kent and just do the everyday mundane work and you'll be fine. You don't need to stay up 3 nights in a row, drinking Red Bulls and all that other stuff. Just do your regular work and you'll be fine. Okay? All right. Any questions about this? No? All right. So policies, be here on time. If you can't make the published office hours, the published office hours are there for you to just show up. And I kind of joke a little bit about it. It's the loneliest period during the week. It's, that student chair in my office for office hours, it's cobwebs. And every week I have to clean off the cobwebs. Some have made use of office hours, but most do not. So please make use of office hours. And if that doesn't meet your schedule, email me so that I can find a time that works for me, mutually agreeable, and I know what you're going to ask me. Because whether you believe it or not, I don't think of this material every single waking moment of the day, right? And it helps me to help you better. All right, so your programs must run and compile. And this might seem cold, but I'm not product support, right? If your program does not compile and run, I reserve the right not to look at it as 0. Please work with me, contact me before it's due, right? I want you to succeed, but you have to help me to help you, okay? All right, I value a distraction-free environment. I am an INTJ, and that'll make sense after today. So please help position your colleagues for success, myself included, and let's minimize the outside distractions. When side conversations happen, it's a small room, can absolutely hear what you're saying. If you have something to share with the class, please do so. I welcome an active environment, okay? Any questions? No? All right. I'm here to help you succeed if you'll let me. And that if you'll let me, it pains me so much when a talented young person does not succeed because there's something that needed a little bit of tinkering, right? Whether you believe it or not, all of your faculty want to see you graduate, be a thriving success, right? Because we get to say, I had a part in that, which is kind of satisfying, right? So please communicate and do not struggle in isolation. Now, this part is very, very serious, this next part. There are 2 URLs, and these are published research that says 1 in 4 college-aged young people has had suicidal thoughts. Life is rough in general, and there are different seasons in one's life where people go through things. It happens, right? And so if you are struggling in some way, please know that there's absolutely no shame in reaching out for help because, mental health is health and there shouldn't be a stigma attached with it. And if anyone ever needs help in that regard and you want to be directed to resources, I'm more than happy to direct you towards those resources. And there are several people at Clark who are both qualified and licensed to do that. I am not, right? But I take it very seriously. Do not struggle in isolation. There's no shame. I promise you that. Okay? All right. Any questions? No? All right. So we are in called COVID operating mode, the other COM, not communication. And of course, COVID is real. We have the Omicron variant, the Delta is still swirling around there. There's breakthrough infections and all sorts of stuff. I will record each class module and lab module and make those recordings available. I will maintain a link for emergency purposes only for live participation, but these recordings are not a substitute for attending class, right? I'm actively trying to cobble together a solution. We only have a certain number of kits, and if somebody has to quarantine and isolate, we'll have to figure out what we're going to do. Okay. All right. Any questions? No? All right. So please bear with me. I'm still new to Clark. I'm also new to Central Mass. I grew up in Boston. It was a great time. And I'm also retraining my muscle memory after 11 years on different systems in a different environment, how to operate as a Clark faculty member. All right. So let's get to the substantive information. We're here for IoT. So what is Internet of Things? Okay. Anyone want to venture to put him or herself out there? What's Internet of Things? What do you think? What do you think? Yes. Okay, you said small microcontrollers, embedded systems. Okay, great. And what's your name again? Adriana. Great, Adriana. So embedded systems and microcontrollers. Would anyone like to build upon this idea that Adriana has introduced? Yes, Jamie. Okay. Okay. Uh-huh. Uh-huh. Okay. Okay, so we have connectivity, the way for things to exchange information, messages. Great. So absolutely, everyone has an intuition about it. IoT is really a symptom of these three things. Well, you had low-cost embedded processors. Absolutely. Because processors in the 70s and 80s, they were prohibitively expensive. So even if you wanted to put one in a washing machine, it would make that washing machine so expensive that no one would buy it, right? Cars never used to have microprocessors. That was when cars were cars. And I remember that when I was a kid, go in the engine and do all sorts of stuff. But anyways, so low-cost embedded processors, miniaturization in your electronics. Well, electronics got smaller and smaller and smaller. So now it would be very easy to fit some embedded processing in an arbitrary device because you can now make electronics very, very small. And this last one, someone, Jamie alluded to, Adriana, right? Okay. I'll learn the names at some point. And please correct me if I'm butchering your name. I'll remember everything about you and forget your name. So please correct me and don't feel shy about that. It's important for me to get it right. And this last one, easy network connectivity. Now, with a network, it doesn't necessarily mean something like the internet, some method of connectivity, because there are many networks that don't involve the internet, like CAN bus, body area networks, and so forth. Okay? So these three things enable this Internet of Things. You have physical objects, and they're embedded with sensors, actuators, and computation, and other technology, and they interconnect with one another, exchanging messages to achieve some application purpose. So that's Internet of Things, and it's really a symptom of these underlying technologies, capabilities, and advancements. And so here are some examples of Internet of Things. This is smart meter and a smart grid. And I remember when I first moved to Delaware in 2006, about 2 years in, they started upgrading the electrical grid to smart grid. And so on the side of a building or a house, you have an electrical meter. And in the early days, someone would come by from the electric company monthly and read it. And this thing measures how much power, how many kilowatts of power you're consuming, and they would bill you appropriately. Now, with a smart meter, you add some computation, some networking, and this networking could be either wireless or there are standards for doing networking over power lines. That's been available for a really long time. And what this thing does is makes it easier to report on the power consumption. Now, sometimes a truck with a big wand drives by and they just read it just by driving by your house. Other times it sends it across the wide area to some station. Now, the other thing that happens with these smart meters is that they can accept incoming information and modulate, tune up and tune down the amount of power that you're consuming. So let's say, in the summertime, at the height of the summer, there are a lot of air conditioners running, and air conditioners are very power hungry. Now, there's something called a brownout. And what a brownout means, there's more demand for power in an area than there is available electricity. So what happens? Boom, it shuts off, it breaks. So now nobody has power. Now, with a smart grid, all of these meters, electrical meters, are reporting the amount of power being consumed. It's collected at some console in a network operations center. They perform some computation or analyses on all this information, and they say, you know what? Let's turn down the power for all of these places. So rather than the electricity shutting off in an area, like a whole town or region, everyone doesn't have as much power as he or she otherwise would have. So everyone gets a little less instead of it just breaking. And that's what you can do with a smart meter. And so here we have sensors at the homes. We have data trafficking back and forth. We have an analysis being performed, and you can send out a command to make an adjustment. Okay, any questions about this? No? Here's another one that's near and dear to my heart, smart parking garages. You have sensors that detect if there are empty spaces in the parking garage on each floor. These sensors send data to a central location. A simple analysis, a sum for each floor, is computed, the number of available empty spaces, and then the action performed is to send it out to a display on a console outside the parking garage. Any questions? So this is immensely useful. And we have this pattern. We have sensors, we send data back and forth, and then we do something as a result of some computation. Okay, any questions? No? All right. And so I'm from a robotics background, so I like to think as everything is a robot, right? And so here we have a robot, and a robot, more formally, is a system or embodied agent. Embodied is really important. It means it has a physical structure, has a physical body. And this embodied agent just isn't anywhere. It's situated in some environment. It's actively a part of the environment, participating in the dynamics of that environment. So we have an embodied situated agent sitting in the environment. It could be outside, it could be a factory, what have you. And this agent is endowed with devices called sensors. And these sensors are responsible for taking a measurement of the environment in some form. Now, more formally, a sensor is a device that translates energy from one form as it exists in the environment to electrical energy. So if you think about what a microphone is doing, sound is nothing more than a pressure wave going through the air. And this pressure wave, when you talk into the microphone, it moves some little electric piezo crystal, and it produces current in a certain sequence. And this current is read by a computer to say, aha, these are frequencies of sound. It's transferring energy from one form in the environment to another. Now, these measurements are input by our system, and it's used to do one of two things or a number of things. It's used to update some representation, and that could be a data structure that you're populating or adding to, or it could be a mathematical model, like a probabilistic model, like we talked about in stochastic computing. Now, this is continuous. It happens again and again and again and again. And so these sensors, like we saw with the parking garage, they're continually saying, is this space empty? is this space full? Now, this representation would be something like, maybe for the parking garage, it's a grid that represents the floor plan of each floor, and you're just lighting up, putting a little 1 in a cell so that when you do the sum, you compute the number of empty spaces on that particular floor. Okay, so this computation is often driven by some objective. And so it runs and then it halts. And after it halts, then the actuators come into play. An actuator, more formally, is a device, and this device does the converse for what a sensor does. You take your electrical signal, electrical energy, and you convert it to some other form of energy, and it takes that other form of energy and projects it into the environment. And so if you look at a speaker for producing music, you have that signal, electrical signal for the sound, talking about the different frequencies constituent that comprise the sound. And these electrical oscillations are used to power an electromagnet in your speaker cone, and it moves back and forth at a characteristic rate, producing a pressure wave that you perceive as sound. And so if you've ever gone to like a Best Buy, they don't like you when you go to the back room, in the back room in Best Buy where the really nice speakers are, and just kind of put your hand near it when it's playing something, it's kind of neat. But anyways, so an actuator is how the system projects energy back into the environment for the purpose of trying to manipulate the environment, either manipulate the environment itself or change its state or its position or something about it within the environment. And so here we have a measurement through our sense action. We have our thinking part, the updating of a model or data structure driven by an objective. And then we have the action part. And so this is called the sense, think, act cycle. And it happens again and again, 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 and again, continuously. And this is how a robot works. Why am I talking about this? Because an IoT system is essentially a robot that has been blown apart. And I'll talk a little bit about that in the next slide. So now let's imagine we take our robot and we shatter it to pieces, and we take these pieces and we scatter them around some network scatter them around an environment. And so each piece, well, when it was part of the robot, they kind of work together. But now that you've scattered these pieces around the environment, you need to add a little bit of computation and a little bit of networking to each piece. Now, certainly here we have our sensors on the left, your left, and the actuators on your right. But the ability to compute something is also a piece of this robot. Because remember, in the think part, we have the updating of a data structure or a model driven by some objective. Sometimes when I think you're hearing what I'm saying, but I'm not saying it and actually thinking it. So I have to catch myself up. Driven by some objective. So absolutely, computation can be a part of this robot that we've scattered around the network. Now, of course, we have these pieces of the robot, our sensory apparatus, our actuator apparatus, our computation, and now we arrange for them to interact in what's called a task graph. It's an arrangement across a network between these various components that now have been enabled with computation and network, and they now exchange messages working together in some protocol to achieve some end. So effectively, your IoT application is just a distributed version of the sense, think, act cycle by taking your robot and scattering its pieces around the environment. Okay, any questions about this? Does that make sense? Yeah, all right. And so we're going to be working in teams. And of course, on a team, you're thrown in together, and this is especially true in a workplace, with everyday people. And I say everyday people because people have all different sorts of backgrounds. And it has been reported that so-called diverse teams produce better outcomes. And there are a whole host of reasons for that. But it's not just a nicety. There are measurable improvements in the work and the decisions of diverse teams. But what exactly is this diversity? Well, when you look up definitions of diversity, there are kind of two major ideas or schools of thought about what diversity means. Now, some will say It's a melting pot. Now, I didn't know what fondue was until I met my wife, right? It was 15 years ago. And fondue is interesting. It's good. Well, it's interesting. But that being the case, this melting pot idea says everyone comes to the table and they assimilate together into one system. They become a homogeneous whole, each bringing something to the table. Now, this other thought about diversity, I call salad bowl diversity. It's not my term, something that someone else, some people say fruit salad, some people say salad bowl. And what salad bowl diversity says is you recognize all the individual bits and their contribution to the overall result. Because if you're making a salad, that little bit of cracked pepper makes a world of difference, right? Anyways, so melting pot diversity, it makes things easy because you have a single framework for how you do things, but kind of carry it too far and everyone becomes one homogeneous average, right? Salad bowl diversity, yeah, all the different parts and what makes them unique contribute and you recognize and celebrate and embrace them, but you kind of carry it to the extreme and you're spending a lot of time trying to cater to individual things. Now, where does it lie? Well, that's up to you to decide. But when we talk about diversity, I personally, this is my own opinion, I'm more on the side of salad bowl than I am on melting pot, right? And so there's good news, but there's also bad news. The good news and bad news is you have to work with other people. Now, when you work with other people, there are things that contribute to the makeup of other people. Some are visible, but many are not visible. And it's those not visible things that can sometimes be the cause of conflict. And this conflict is never intended because no one wakes up a monster. No one wakes up in the morning and says, let me see how much chaos and destruction I can cause today. Right? No one does that. Oftentimes, there's a personality mismatch whenever conflict occurs. And so how do you understand others when sometimes we don't even understand ourselves? Well, everybody carries his or her unique background. Now, obviously, let's say if this was your team. Now, obviously, you can see that there are differences among people, but there are the hidden differences that contribute to how people interact in the world. So let's say the person on the left, your left, is very reserved, very proper, very reserved, somewhat low key. And let's say the other is a homebody. You know, she likes to stay at home, enjoy the warmth of a familiar environment, doesn't seem to go out and do a lot of different things. Maybe there's someone else who likes to work individually, right, by himself, tucked away in the crevices of the library somewhere, far flung. And then this last person, maybe he's an outgoing star athlete, has a full Rolodex and seems to know somebody everywhere he goes. Okay. Well, what you wouldn't know is that this reserved classmate, she's been doing extreme sports since she was a kid. And she likes to spend her weekends rock climbing and is very adventurous and skydiving. But you wouldn't know that from what you see in the outward appearance. Maybe the homebody is an elite soccer athlete. She's been doing that from the time she was a little girl. And she spends every Friday traveling up and down the Eastern Seaboard going to tournaments. Okay. And this person who works individually might seem like a loner, but he grew up in a huge family and spends every weekend boisterous family conversation every weekend. And then maybe this outgoing star athlete might seem like a very social person. Maybe he grew up cooking with his grandmother and spends his weekends quiet, right? So it's a lot of times the hidden or latent attributes that govern how someone interacts with the world, but you wouldn't know that unless you took the chance or the time rather to get to know them, right? Okay, many questions? All right, so here's an example, and we'll talk a little bit about this. So suppose it's last semester, and you're working on my stochastic computing Bayesian modeling homework, and you're paired with a partner, person on the left and the person on the right. And you're working on a problem. So blue person says, let's see now. First, we take the integral. Maybe you're doing max likelihood estimation. First, we take the integral. Now, this person on the left, brown person, is thinking, oh, why won't they just shut up? I'm trying to think, right? So then we multiply by a scaling factor. Blue is still going on and on and on about how to solve the problem, but brown is still thinking about it, thinks internally. So then brown's like, oh my God, will you please stop? I'm trying to think. So then brown has had enough, and blue says, you're kind of quiet. You must be confused. Let me start with the integral again, because obviously you're not saying anything. You must be confused. So then brown says, just move on. Shut up, move on. And then blue says, someone's a cranky jerk. Someone woke up on the wrong side of the bed today. Now, what happened here is a mismatch. And the mismatch for the person on the right, that's an extrovert, a classic extrovert. And the person on the left is a classic introvert. Now, with a little bit of understanding about different ways people interact, make decisions, and so forth, you can model a better way to interact with one another for more successful interactions. Okay, any questions? No? All right, so this personality type was created by Carl Jung, and Carl Jung. I took German for 7 years, so I should, Carl Jung, and he created analytical psychology. Now, my one disclaimer is I'm not a psychology PhD. I'm just using what is the Myers-Briggs type indicator. So if you're interested in this sort of stuff, I would recommend you go to a psychology professor wherever they are on campus, right? But he developed what's called the theory of personality. And it's based on archetypes or patterns of behavior. Because people are not random, they're stochastic, right? They have these repeatable patterns. It's how we make it in the world with repetition or regularity. And so two other psychologists came along, Myers and Briggs, and they shortened this framework into a test that's called the Myers-Briggs personality test. Now, this personality test is not to say one personality is better and the other is not. It's an assessment tool to try to help you figure out different ways that people operate in the world so that when you interact, you can model and shape your interaction in a way for smoother team interactions. Okay? Any questions? All right. So this is based on 4 axes of measurement. The first is how you respond or interact with the world. The second is how you gather information. The third is how you make decisions from the information you've gathered. And the last one is how you orient yourself, how you deal with things that are external. Now, the first one, interaction with the external world, there's a dichotomy. The 2 levels or 2 categories are called introvert and extrovert. Now, an extrovert is somebody who's external. An extrovert, when they interact with people, they get energized by interaction. An introvert, the converse, an introvert has to put work into interacting with people. An introvert interacts with someone and they have to go and relax and, right? And so extroverted learners enjoy generating energy and ideas from other people. And I won't read all of these, it's just there for your information. But they learn best through direct experience, interacting with others, with an emphasis on the social interaction, talking with people, meeting people. An introvert prefers to solve things on their own because introverts tend to be in their mind reflecting. It doesn't make one better, one worse. It's just 2 different things. Right? And so the example that I showed you with blue and brown, well, the person on the right was extrovert, the person on the left was an introvert. And so if you're working with someone and they're introvert, you need to give them time to think. If you're introvert and working with someone who's extrovert, you have to give them time to talk and you have to find a way to meet in the middle. But knowing that will help you with smoother interactions with your teammates. The other one, how you gather information, sensing versus intuitive. So sensing people, like sensors, they take in information as it happens. They're interested in the external world, right? People who are intuitive, they traffic in possibilities. Now, I'm a John F. Kennedy fan, right? And Kennedy said, some see things as they are and ask why. I see things that never were and ask why not, right? That is the sensing versus intuitive. Intuitives ask why not. They think about the possible, not what they see. Okay? All right. Any questions about this? No? All right. And then how you make decisions, thinking and feeling. Thinking, they run a logic engine. They look at very crisp things and they make these crisp decisions based on logic and reasoning. Feeling, they look at the feelings, the relationships. How will they be? My wife is feeling, I'm more thinking. And we've learned how to interact with one another quite well. Now, the last one, how you deal with the world, judging versus perceiving. Now, people who judge, they like order and structure. They like to plan things out. People who are perceiving, well, they focus on their curiosity. This is interesting. Let's take a look at this. Let's go and do that, right? And so when we take these four axes in Jungian personality types, we take the dichotomies for each of these axes and we ascribe a letter to each one, introvert versus extrovert, sensing versus intuitive, thinking versus feeling, and judging versus perceiving. We write out these four letters for your types, and this is what you're characterized as. I am an INTJ, right? I've been an INTJ for a long time, and there are people in my life, in my family, who are completely different, right? And this has helped me tremendously, in addition to in the workplace when I was in industry, in navigating through group dynamics, specifically in organizations where the team function was really, really important. All right. And so there are a total of 16 types, 2 choice per axis. And part of project 1 is for you to take a Myers-Briggs type test. And you don't have to share it with anyone, but I'd ask you to hand it in so I get to see it, so I can get to know you. But also what it will do is you're going to be thinking about 2 different archetypes, somebody who you interact with regularly and the interaction is not smooth, call that person smooth to protect his or her identity, and someone who you interact with who their interaction with them is very smooth, right? And try to think about what you think their personality type is and how you might improve that interaction that's not smooth, okay? And that's going to be our first assignment. And you're going to brainstorm with your team members about that. Okay? All right. And so let's take a look at a revised interaction between blue and brown. So we start again. They're working on a stochastic computing modeling assignment. Blue says, let's see now. First, we take the integral. Brown says, why won't this person just shut up? I'm trying to think. They just broke my concentration. So then Blue says, I see you're thinking. I'll wait a little bit before discussion. And then they start thinking. So Brown then says, oh, we take the integral and then multiply by a scaling factor. And then Blue says, are you all set? Yeah. Did you get the integral and scaling factor? We have the same answer. Yay. Blue is being social. And now they both think they work well together. And so the idea then is that you build a mental model for your colleague, and I have all the Myers-Briggs types in a detailed description listed on a Dropbox folder in course resources on the Moodle site. And you figure out how you might best interact with this person. This idea of recognizing differences, i.e. salad bowl diversity. Okay? All right, any questions about this? No? All right. So here's a really quick one because I promised 5 minutes at the end. We have about 2 minutes left. Before the 5-minute mark. If you have an introvert and you're interacting with someone who's introverted, they think internally, they dive into tasks and they don't switch very easily. They can be pulled out of their concentration very easily. Distractions pull introverts from their focus. If you're going to, small talk is difficult for an introvert. How do you interact with an introvert? Give him or her time to think. And so one thing I do in my class, I'll try to see who the introvert is, and I'll call on the introvert, knowing that he or she needs to think a little bit more and say, okay, let's think about that. And I'll go around the room and come back to you. That's recognizing those differences, the salad bowl diversity. So give the person time to think, value the quiet time. right? Quiet time doesn't mean confusion. And if you're going to call somebody who's an introvert, don't just call him or her. Text message them, say, hey, I was thinking about calling you this afternoon. Is that a good time? Yeah, sure. And they're expecting you, right? So the funny thing is that, sometimes my wife will say, didn't you get my text message? I say, I didn't look at my phone. In my opinion, my cell phone is for my convenience, not the person who's calling me. And so you leave a message or send a text. But I digress. Anyways, so if you're dealing with an extrovert, extroverts think externally, they think out loud, and they gain energy from social interaction. And they really value the social interaction. And so give this person time to talk. Don't cut off an extrovert. It does not go over well. Offer them a challenge and be positive, because that reinforces the positive social interaction. Okay, any questions? No questions? That all makes sense? All right, so what you're going to be doing is investigating models for interaction using the 4 Jungian functions. And these 4 axes are interaction with the external world, gather information, decision-making, and how you deal with the world. And so I've posted actual MBTI Myers-Briggs Type Indicator Institute descriptions on the Moodle site. And so part of your assignment will be to familiarize with them. And for many of you, it'll be like, oh my gosh, this is exactly so-and-so, or this is exactly me. When you take the MBTI test, and I have a link to it, it's the extended version, don't think too much about the questions. Answer them promptly with the first idea that comes into your head, and don't think too much about it, because then we can convince ourselves, they're trying to determine if I'm this, so I'm going to shape the test that way. And it's not a test of assessment, it's participatory. You get the full 20 points on the assignment, on that portion of the assignment. If you do it, you don't get the 20 points if you don't do it. So it's not evaluating anyone's or analyzing anyone's personality. It's just to give you some tools for improving group interactions. Okay? Any questions? Now, what does this have to do with IoT? Well, you're going to be working in teams quite a bit, and it's really important for part of the curriculum to career about how to look at group interactions. And in industry, in many industries, especially the consulting field, they do this for real. They really, really take it seriously. So hopefully this is useful to your careers. So we'll end there, and I'll give you 5 minutes with, we have about 3.5 minutes left. I'll give you about 3 minutes if you wanted to chat a little bit about, I guess, getting to know each other. By Wednesday night, please give me your groups, so that I can assign kits. So let me stop the recording,